We have given function f. This function is equal x minus, and in brackets we have x. It means we have to take the largest integer that is less than or equal x. So first we have to sketch the graph. To sketch the graph we need few points. So let's draw the table. X row, and the second will be value f of x equals x minus in brackets x. So I will choose negative 2, negative 1.5, negative 1.3, negative 1, negative 0.8, negative 0.5, negative 0.4, 0, 0.2, what else? 0.4, 0.5, 0.6, 0.7, 1, 1.2, 1.3, 1.4. We see that we have in our formula of our function only subtraction. We can subtract every real number. So the domain for this function is all real numbers. So I can choose any x. So now I have to find the value for this x which I choose. We have to copy negative 2 minus, and in brackets we have negative 2. Negative 2 we just copy, and we have minus the largest integer that is less than or equal negative 2 is negative 2. So negative and negative will be positive. 2, this is equal 0. We have first point negative 2, 0. The second, we have to replace x by negative 1.5. So we will have negative 1.5 minus, and in brackets we have negative 1.5. So we have negative 1.5, and we have take the largest integer that is less than or equals x. The integer which is less than negative 1.5 is negative 2. So we have negative, and negative will be positive 2. So this is equal 0.5. So we have second point, negative 1.5, first coordinate, and the second 0.5. Now we have negative 1.3 minus, in parentheses, negative 1.3. So we will have, this is equal, negative 1.3 we just copy, minus, and the largest integer that is less than or equal negative 1.3, it will be negative 2. So negative and negative give us positive. So this is equal 0.7. So we have second point will be first coordinate negative 1.3 and the second 0.7. Next we have negative 1 minus, and in brackets negative 1. So this is equal negative 1 minus, and the largest integer that is less than or equal -1 is -1. Negative and negative will be +1. This is equal 0. Next we have -0.8 minus, in brackets, -0.8. This is equal -0.8 minus, and we have the largest integer that is less than or equal -0.8. We have +1. Negative and negative give us plus, will be 1. This is equal 0.2. And we have -0.5 minus, in brackets, -0.5. So this is equal -0.5 minus, and the largest integer which is less than or equals, we have -0.5, so it will be -1. Negative and negative give us positive, so this is equal 0.5. Next we have -0.4 minus, in brackets, -0.4. This is equal -0.4 minus -1, so will be negative and negative will be +1. This is equal 0.6. Now we have 0 minus, in bracket 0. This is equal 0. Now we have 0.2 minus, in bracket 0.2. So we have 0.2 minus the largest integer, which is less than or equals, will be 0. So this is equal 0.2. Next we have 0.4 minus, in bracket 0.4. So will be 0.4 minus the largest integer, which is less than or equals, will be 0. So this is equal 0.4. So we see the same will be here. We have 0.5 minus 0.5, the largest integers, which is less than or equals 0.5. So it will be, we just copy 0.5 minus 0. This is equal 0.5. So we have 0.6 minus, in bracket 0.6. The largest integer for 0.6 will be 0. So this is equal 0.6. Next we have 0.7 minus, in bracket 0.7. This is equal 0.7 minus the largest integer, which is less than or equal 0.7. So this will be 0. This is equal 0.7. Now we have 1 minus, in brackets 1. So 1 minus 1 will be 0. Now we have 1.2 minus, in brackets 1.2. 1.2 minus the largest integer, which is less than or equals 1.2, is 1. So it will be 0.2. 1.3 minus, in brackets 1.3. This is equal 1.3 minus 1. So we have 0.3. Here will be 1.4 minus, in brackets 1.4. This is equal 1.4 minus the largest integer that is less than or equal 1.4. The less will be 1. So this is equal 0.4. So we have points -1, 0, -0.8, 0.2, -0.5, 0.5, -0.4, 0.6. Next we have 0, 0, and 0.2, 0.2. We have 0.4, 0.4, 0.5, 0.5, 0.6, 0.6, 0.7, 0.7, 1, 0, 1.2, 0.2, 1.3, 0.3, and 1.4, 0.4. Like you see, the x, it means the first coordinate can be every real numbers, but we see that the second coordinate is always positive and is never greater than 1. We have 0, 0.5, 0.7, 0, 0.2, 0.5, 0.6, 0.2, 0.4, 0.5, 0.6, 0.7, 0. So the last number is 0, and we see that never we will get for y number greater than or equals 1. So let me draw xy coordinate. We have to choose unit, and we don't need negative value y, so that will be 1, 1, negative 1, and the first point we have negative 2, 0, negative 2, 0. Next we have negative 1.5 and 0.5. So approximate will be here. Next we have negative 1.3. So will be just here. And value is 0.7. So we can write here. Next we have negative 1, and for negative 1 we have value 0. Next, for negative 0.8 we have value 0.2, negative 0.8, and value is 0.2 approximately here. Next we have negative 0.5 and the value is 0.5. Next we have negative 0.4 and we have value 0.6. Next we have 0. For 0 we have value 0. For 0.2 we have value 0.2. For 0.4 we have value 0.4. For 0.5 we have 0.5 value. For 0.6 we have 0.6. For 0.7 is 0.7. For 1 we have value 0. For will be 2, 1.2 will be approximately here. We have value 0, 2. For 1.3 we have value 0.3. For 1.4 we have value 0.4 approximately here. We see that we never get value 1, so we can draw circle on value 1, and our graph we can just connect. If you choose some more points, you see that our graph will be just these pieces should be parallel to each other. This is graph our function. The value of our function, the range of our function, the range, we see y belongs to interval from 0 to 1, and we see that 0 belongs to this interval from 0 to 1. This is our range for our function, and the domain is all real numbers. And now we have to find the limit when x approaches n, and n is integer, from the right side and from the left side. So let's write this. We have limit of x approaches n from right, n is integer. So it means it's 0, negative 1, 2. Let's see what we have when we approaches negative 2 from the right side. We see the value is 0. When we approaches negative 1, the value is 0. When we approaches 0 is 0. When we approaches 1, the value is 0. So limit as x approaches n from right side, f of x is equal 0. What about our limit as x approaches n from left side, our function f? We are going now to, because n is integer, so we are going, for example, to negative 1 from the left side. When we are going from the left side to negative 1, we see that we are going to value 1. One close to value 1. When we are going to 0 from the left side, we are going to value 1. When we are going to value 1, we are approaches 1. When we are approaches 2, x approaches 2, we are going again to value 1, always 1. So we can write the limit as x approaches n from left of f of x is 1.